Welcome to the final program of this academic year of the Sarum seminar. We're pleased that we get to end on the high note of having Chet Van Duzer again. He gave us a talk many years ago, you'll remember, on sea monsters. So we're thrilled that you're here with us again. I see your background as the Rumsey Map Center, even though that's not where you are.
That's right.
But it's recognizable. And thank you so much for agreeing to talk to us. We're looking forward to this and learning about the Lazarus Project, which is fascinating. So it's all yours now.
Okay, thank you very much. It's a pleasure to be back. It has been a while. So, new light on Henricus Martellus's world map at Yale from circa 1491, multispectral imaging and early Renaissance cartography. So here is the map that I'll be talking about this evening. It surfaced in Bern in Switzerland in the late 1950s, and it was anonymously purchased and anonymously donated to Yale University, where some studies were made of the map, which, for reasons I've never understood, were never published. But they acknowledged the map's genuineness and affirmed its importance. And then the map remained at Yale, not entirely, but almost unstudied for about 60 years, basically because most of the writing on the map had faded to illegibility. And I got interested in the map and set about finding the right technology to try and make the map a studyable object again, and got a grant from the NEH to support that project. And in the end, I think it's fair to say that the project was pretty successful. So that's what I'll be talking about today. So I'll begin by giving a little background about Henricus Martellus and the development of his world maps. He was a German cartographer active in Florence in the second half of the 15th century. We know very, very little about him. But we do know that he made two manuscripts of Ptolemy's geography, and he made some island books, as they're called, so books about islands illustrated with maps, and a couple of separate world maps. But we'll begin with Ptolemy's geography. So here's a folio in a manuscript of Ptolemy's geography. The geography was composed in the 2nd century AD. It consists of a database of about 8,000 place names with their latitudes and longitudes, together with instructions for making maps. And we see here a folio from a manuscript of Ptolemy's geography that shows us some of that database with the place names with the latitudes and longitudes. Ptolemy came up with a couple of different projections for his world map, which is to say a way of trying to represent what is part of a spherical surface on a map that is a plane. So here is his second projection. And here we have the equator. Here we have the Tropic of Capricorn, which is at about 23.5 degrees south, which is the southern limit of knowledge for Claudius Ptolemy. Here we have the Tropic of Cancer at about 23.5 degrees north. And here the Arctic Circle at about 66.5 degrees north, which for Ptolemy was the northern limit of knowledge. And he shows about 180 degrees of longitude. So he's showing only, he's not showing all the way to the North Pole. He's not showing anywhere near the South Pole, and he's only showing half of the Earth's 360 degrees of longitude. And he was very conscious of the fact that he was only showing a portion of the Earth's surface. So if we keep this, this diagram in mind, I now switch to a world map in a manuscript of Ptolemy's geography that is made on his second projection. And this is a manuscript that was made by Henricus Martellus, which is in Florence at the BNCF. And we don't see a map like this every day. So just to orient ourselves a little, here's Europe, the Mediterranean, Africa, the Arabian Peninsula, Asia. And it's worth pointing out that Ptolemy does not know the eastern coast of Asia and the Indian Ocean and the island of Taprobana, which is usually identified with Sri Lanka. So, as I mentioned, in addition to making manuscripts of Ptolemy's geography, Martellus also made island books, these books about the islands of the world. And some of the surviving manuscripts are illustrated with world maps. And this is the most commonly reproduced of those world maps, which is in the British Library manuscript of his island book. And if we compare it with his world map in Ptolemy, it shows a larger part of the Earth's surface. So the Ptolemaic world map, as I mentioned, shows 180 degrees of longitude, and the world map that we see below from his island book shows about 240 degrees of longitude. It doesn't have a scale, but we can see that it shows all the way to the eastern coast of Asia. And it's also worth pointing out that it goes further to the south as well. We see the southern tip of Africa, for example. And then if we compare the world map in Martellus's island book, his Insularium, with this very large world map at Yale, he again extends his image of the world to include now 280 degrees of longitude. So we can see that his willingness to depict more and more of the Earth's surface increases over time. And in this case, he extends that image of the world by showing not just the eastern coast of Asia, but an ocean east of Asia, and at the very eastern edge of his map, Japan. So the source that he's using for extending Ptolemy's vision of the world eastward is Marco Polo. And it's easy to draw the line that separates those two sources of information. Ptolemy goes to 180 degrees east, and then beyond that, we have things that come from Marco Polo. So what is the importance of this map? Why was I keen to learn more about it? Why did the NEH fund this project? And I think there's three main reasons the map is important. First, it very likely influenced Christopher Columbus's thinking about the shape of Asia and location of Japan. So Columbus's son, in his biography of his father, says that his father, would certainly have discovered Japan had he not believed that the island's main axis ran north and south. And there are other pieces of evidence that this cartography, if not this precise map, because Martellus, even though this is the only one like this that survives, he no doubt made others. There are other pieces of evidence that Martellus's cartography influenced Columbus, but this is the only depiction I know of that shows Japan with its main axis running north and south. There's no text that precedes Columbus and no other maps before Columbus's time that ascribe that orientation to Japan. So strong evidence that Martellus's cartography influenced Columbus. And here we have Japan with its main axis running north and south. And it looks like it's at an angle, but that's just because of the projection that Martellus is using. Second, Martellus's cartography influenced Martin Beheim in the creation of his terrestrial globe of 1492, which we see here, We know that globes, that terrestrial globes were made earlier than this, even back in classical antiquity, but as it happens, this is the earliest one that survives. It's in the German National Museum in Nuremberg. And if we look at Southern Asia on the two maps, they're remarkably similar. And what in the eastern part of these two images, what we're seeing comes from Marco Polo. Marco Polo does not give latitudes and longitudes for the cities he discusses. He says that this city is 15 days east of that city. And trying to make a map based on Marco Polo's text did involve a lot of extrapolation and guesswork, and it's supremely unlikely that two people would make a map based on Marco Polo that ended up being this similar unless one influenced the other. And this influence is even more clear when we look at the eastern coast of Asia, where on both the globe and the map we have this triangular peninsula jutting eastward from Asia, and in both cases it's just above the tropic. So that's the second reason Martellus's map is important, is that it influenced Martin Beheim in the creation of his globe. And the third reason it's important is that there are striking similarities between Martellus's map and Martin Waldseemüller's 1507 world map. Some of these similarities were recognized when Martellus's map was discovered, when it surfaced in the late 1950s. And I'll go through some of those similarities in a moment, but it was impossible to determine just how close the relationship was between the two maps, precisely because the text on Martellus's map had faded to illegibility. So this connection, it was recognized that there must be a connection between the two maps, that Martellus's map must have served as a source for Waldseemüller, but it wasn't possible to go any further with that investigation. So a few words about Martin Waldseemüller's world map of 1507. We see its dimensions here. It's a wall map printed in 12 sheets. It's a printed map, but only survives in one exemplar, which is at the Library of Congress, and was acquired by the Library of Congress from a prince in Germany in the early 1990s. It's famous for being the first map to apply the name America to the New World, and thus has been called the birth certificate of America, and that was why the Library of Congress was interested in acquiring it for decades. If we compare the two maps, they are of similar dimensions. Both cartographers take advantage of the margins left by the projection to include large text blocks in the lower corners of the map. The shape of Africa is very similar in the two maps. That in and of itself is not good evidence of influence, because in both cases, the shape of Africa is Ptolemaic. It goes back to Claudius Ptolemy. But if we look at Eastern Asia on the two maps, here we do indeed have very strong evidence of influence. As I said, the eastern part of Asia comes from Marco Polo. Marco Polo doesn't supply latitudes and longitudes, so making a map based on Marco Polo would involve a lot of extrapolation and guesswork. And it's supremely unlikely that two people would make a map based on Marco Polo, and the maps would end up being this similar. And we can also point out that Japan has the same shape, the same orientation, and the same location on the two maps. And Marco Polo says very, very little about the shape of Japan. So again, very strong evidence of influence. So the problem with the Martellus map, as I said, is that almost all of the text on it has faded to illegibility, which made it very difficult to really do much of anything with the map, to investigate it and to determine its place in the history of 16th century European cartography. To give some idea of the degree of fading, here we see northeastern Asia in natural light. Hardly any text is visible. We can see that there are a few banners indicating the names of regions. But given the map's size, we would imagine that it would have descriptive texts. And if we look at it closely, we do see some. So this is the most legible text in northeastern Asia. We see that there's text there. We can see letters. But trying to string them together into words would be extremely difficult. And this, as I said, is the most legible text on the map. So very tantalizing, but not something one can really do much with. Here is the island of Japan in natural light. No text is visible. But we would expect there to be text, descriptive text on Japan, not just because of the map's large size, but also because Martellus made this map of Japan in his island book. This is in the Florence manuscript. And we see that it has two descriptive texts on it. So it would be reasonable to think that he would put some sort of descriptive text, even if not exactly the same descriptive text, on Japan on his large world map. So what is the solution? How can we access the information that is hidden in this large and important world map? So the answer is multispectral or hyperspectral imaging. And this is a technology, the basic idea of which is that one takes digital images of the object of interest at specific frequencies of light. And those frequencies range from the ultraviolet through the visible spectrum into the infrared. Usually, each of those images, or at least some of them, will reveal something about the object. And the idea is, in stating matters in a very succinct manner, is that one digitally combines those images into one image that combines what is revealed by each of those images into one. So this is a technology that is useful for recovering text from documents damaged by fading, water, fire, overpainting, palimpsesting, or wrinkling. And if we think about a manuscript damaged by fire, let's imagine it's a manuscript where there's text written in pen with, say, black ink. After a fire, you would have black ink on what has become a black substrate. Very difficult to read, but there are nonetheless differences between the inked and uninked surfaces that multispectral imaging is able to distinguish and thus recover text. And this technology has also been famously used in the Archimedes palimpsest to recover some unique texts by Archimedes that don't survive in any other manuscript. And there were some indications that the Yale Martellus map was a good candidate for multispectral imaging. Going back to northeastern Asia in natural light, again, hardly any text is visible. When the map was acquired, some ultraviolet images were taken of it. And very early in this project, I wrote to the Beinecke Library and was able to get scans of some of those ultraviolet images of the map. And here is exactly the same part of the map in one of those images. This was one of the most exciting images of a map I had ever seen. It shows that there is text everywhere on the map and really brings home the importance of finding a way to access that text. Here we have an image in natural light on the left and an ultraviolet image on the right. This is a more recent ultraviolet image of the map. And it very dramatically indicates what the ultraviolet light reveals. It makes the whole river system much more visible. And because multispectral imaging includes ultraviolet light, this is a good sign that multispectral imaging would be successful on this map, that the map was a good candidate for multispectral imaging. Just to give one other example, here's the southeastern tip of Africa in natural light. Here it is in infrared, and we can see that the details of the rivers and the names beside the rivers become much more visible. And this is another great indication that multispectral imaging would be successful on this map. One more example, looking at Africa natural light. There's a text here which you have to use your imagination to see that there's anything there in natural light. And here it is in ultraviolet light. Again, a very strong indication that multispectral imaging would be successful on the map. So having learned about the existence of multispectral imaging, I found a group, the Lazarus Project, that brings multispectral imaging to cultural institutions around the world. I approached them with this project. They were immediately interested. We were able to get an NEH grant to go to the Beinecke and image the map in August of 2014. Here is the team. That's me on the left, of course. That's Ken Boydston next to me. He is the CEO of a company called Megavision that makes equipment for multispectral imaging. In the middle, it's Roger Easton of the Rochester Institute of Technology. He was responsible for doing almost all of the processing of the images on this project. Next, we have Michael Phelps, who runs a project to do multispectral imaging on palimpsest manuscripts in St. Catherine's Monastery in the Sinai Peninsula, which is the oldest continuously operating library in the world. And on the right, we have Gregory Hayworth. At this moment, he was at the University of Mississippi. He's now at the University of Rochester, and he's the director of the Lazarus Project. So here's the map removed from its case. We shipped this enormous easel to the Beinecke to support the map. That's the camera to the right. So we used the easel to move the map in front of the camera. When you're doing multispectral imaging, it's very important that the spatial relationship between the camera and the lights remain constant. So those remained in place, and we moved the map in front of the camera to image it. Just another view. This sort of metal crossbar here are the laser focusing devices. I should mention that the amount of that multispectral imaging does not damage the document at all. The amount of energy involved is less than that the object is suggested to just by ordinary ambient lighting in a library. So this allows us to see the equipment a little bit better. At the top, we have the multispectral LED light source. So these lights shine only the desired frequency on the object, which means that it's a very small amount of energy. And then we have a diffuser between the light and the map to ensure that the light is evenly distributed on the map. For the purpose of the project, we divided the map into 55 overlapping tiles, overlapping so that we could stitch the tiles together when we were done in order to create an image of the entire map. And we did this dividing into tiles so that we could image at the desired resolution. So for this project, we spent a total of 10 days at the Beinecke. We actually imaged the entire map twice, negotiating the access and getting the NEH grant took a fair bit of time and effort, and one wants to be absolutely sure that you get good data, so we imaged the whole map twice. As a result, one spends a lot of time in the dark with these different colored lights flashing. The whole process is, all the exposures are controlled by computer. It's a fascinating process to watch and learn about for about the first 10 minutes. And then once you understand it, it's a bit like watching paint dry. So you hope that your colleagues have good stories to tell as you're sitting there in the dark with these lights flashing. And fortunately, we did have some good stories to tell. So after that very long preamble, we get to the results. And I'll begin with this text block in the lower right-hand corner of the map, which we see here. Again, we can see that there are letters. We can see that there are words, but trying to string those letters into words would be extremely difficult. Here's an infrared image of that same part of the map. One can see maybe a handful more letters here, but that's about it. Here is that same part of the map in ultraviolet light, which for whatever reason was not helpful at all. And here is the multispectral image. The text is suddenly completely legible. And this series, I think, demonstrates very clearly the power of multispectral imaging. So in the past, people have used infrared light and ultraviolet light to try to read faded texts in manuscripts. And this shows very clearly how much more powerful multispectral imaging is. So if we look at some other parts of the map, here we have the Alps. Zooming in, here it is in natural light. It really is that much of a murky mess. This image is not out of focus. And here is the multispectral image. There are place names everywhere. Going to Northern Asia. Again, here's the natural light image. Here's the multispectral image. The left here and at the right here, we start to see some of the longer descriptive texts that I'll talk more about later. In Japan, if we zoom in again, in natural light, no text is visible. Here's the multispectral image, or a multispectral image. The text appears, and it looks great until one starts to try to transcribe the text. And one realizes, as I did, that there are letters missing, that these words were supposed to go all the way to the eastern shore of the island. And when I realized this, I contacted Roger Easton, who was doing the processing of the images, and asked him, is there anything you can do to try and bring out those additional letters? And fortunately, he was able to, and we see the results of that here. Now the letters go all the way to the edge of the island. So this brings up the importance of image processing, or Roger, can you give it one more try? So we spent 10 days in the Beinecke imaging the map. It is not the case with multispectral imaging that you take the images and the damaged text suddenly appears. The magic is in the processing. And in this case, the processing took months of Roger sending me processed images. I would read all the text on them that I could, and then make a PowerPoint circling the areas that I still couldn't read and asking Roger if he could try to reveal the text in those areas. And this collaboration between the person studying the object and the imaging scientist projecting the images is absolutely essential. And this project, the processing for this project was particularly complicated because it turned out that Martellus was writing texts on the map in different pigments that responded differently to light. So if we zoom in on India, we can see that there are three texts at the top of the map, which the multispectral imaging reveals quite well. But I want to focus on this area where we do not see any text in this processed multispectral image. Nor do we see any here, nor do we see any here. But here, suddenly we see text. And this happened to us again and again and again with this project, that I would ask Roger, can you do something to try and reveal the text in this spot? And he would try something that might or might not work with that particular area, but the new image would reveal text in an area where we hadn't known there was any text. Looking at another example in Northeastern Asia, area we've looked at a few times now. So here's a multispectral image of that same part of the map. It's worth going back and forth a little bit. The multispectral imaging doesn't just reveal text, it reveals the mountain ranges and helps us see the details of the river systems as well, and also see cities, for example, here and here and here. The multispectral image in this case reveals these two texts quite well. But in these other areas, it shows us the lines that Martellus made in order to guide the writing of the text, but does not reveal the text itself. And this is another illustration of the fact that Martellus was using different pigments to write different texts on the maps. And so Roger had to find a different processing technique to successfully reveal these other three texts. And it's worth mentioning that the mere fact that the texts on the map are written with different pigments is something you would never guess looking at an image of the map in natural light or looking at it firsthand. So we were quite successful in recovering texts from the map. I would estimate that we were able to recover a bit more than 90% of the texts on the map. So what can we do with those texts? Well, one thing we can do is investigate just how close is the relationship between Martellus's map and Waldseemüller's. So we'll begin in Africa. And I show here this part of Africa in natural light. We can't read the text at all. In the multispectral image, we can. And there is a text in the corresponding spot on Waldseemüller's map. And if we transcribe, what I've done here is underline the words that are the same. So it's the words that are not underlined that are different. But we can see that we have largely the same text in the same spot on the two maps. And this is very strong evidence of influence. And if we translate, the text says, here there are great wildernesses in which there are lions and big leopards and many other animals different from ours, meaning different from European animals. Looking at another spot in Africa, again, here's the natural light image, the multispectral image. There is a text in the same spot on Waldseemüller's map. Here is the transcription. In this case, again, it's the underlined words that are the same. So there's just two words of difference between the two texts. And translating, it says, the Chersidras or Celadras is born here, a serpent that causes the ground to smoke. Moving into the Indian Ocean, again, the natural light image. In the multispectral image, we can read the text in this cartouche. There is a corresponding cartouche on Waldseemüller's map. And in this case, there is just one word of difference between the two texts. So again, very, very strong evidence that Waldseemüller was relying on Martellus. And translating, it says, here is seen the orca, a sea monster that is like the sun when it shines, whose form can hardly be described, except that its skin is soft and its body huge. In Asia, again, the natural light image. Now the text is legible in the multispectral image. It's worth pointing out that in this case, it's not just that these texts are at the same, let's say, latitude and longitude on the same maps, but in both cases, they're in a valley between two mountain ranges. And again, there's just one word of difference between the two texts. And it says, here there are monsters similar to men, but with ears so large that they cover their whole bodies with them. So these are the panotei of classical and medieval legend. One of the so-called monstrous races. Moving into Southern Asia, again, the natural light image, multispectral image, the corresponding image on Waldseemüller's map, and again, just one word of difference between the two texts. Martellus says "heek" here, Waldseemüller says "ibi" there. And the text says, here there are many animals different from our animals, again, meaning different from European animals. So we've seen that Waldseemüller copied quite a bit from Martellus. It's worth mentioning that the Library of Congress paid $10 million for Waldseemüller's map. So did they spend $10 million on a map that was basically just a copy of another? And fortunately, the answer is no. So if we go back and compare Africa on the two maps, as I mentioned earlier, the shape of Northern Africa is very similar on the two maps, but the shape of South Africa is very different on the two maps. And this immediately demonstrates that Waldseemüller was not just copying from Waldseemüller's map, from Martellus's map, rather. We zoom in on part of the western coast of Africa. I've chosen a spot here which is a bit to the north of where there's that dramatic difference in the shapes of Africa. So this is an area where we might imagine that the coastal place names were very similar. We zoom in on Martellus's map. Here it is in natural light. The place names are not just illegible, they're invisible, but the multispectral image is very helpful in recovering them. And here is the corresponding part of Waldseemüller's map. We can see that the place names are actually more numerous on Waldseemüller's map, and going through them and comparing them one by one, they are actually completely different. And what that tells us is that Waldseemüller found a different, and in this case, more recent source for the place names on the coast of Africa. And we here start to get some insight into how Martin Waldseemüller went about creating his map. He was certainly copying some things from Martellus, but it's a much more complex creation than that. He was being judicious in which sources he used for which parts of the map. We look at the Arabian Peninsula. This is one of the few parts of Martellus's map where one could actually read some place names without multispectral imaging. Nonetheless, the multispectral image is extremely helpful. And here is the corresponding part of Waldseemüller's map. In both cases, everything we see comes from Claudius Ptolemy, comes from Ptolemy's geography. There's no new source that Waldseemüller is availing himself of here. And we might imagine, that being the case, that Waldseemüller would just copy the place names that he saw on Martellus's map. But he did not do so. He made a completely independent selection of place names from Ptolemy. I've circled here the place names that do appear on Martellus's map that do not appear on Waldseemüller's, and here the place names from the central part of the peninsula that appear on Waldseemüller's map that do not appear on Martellus's. So we again see that Waldseemüller is not relying on Martellus for place names so much. We look at the Northern Ocean on the two maps. Again, the natural light image, the multispectral image. So we have two texts with an island in between, and something very different on Waldseemüller's map. There are little islands on Waldseemüller's map, but not the same shape, and the texts are actually completely different. So Martellus is talking about an island in the Northern Ocean with descriptive texts from Pliny, and Waldseemüller does not show the same island, and he has a text from Pomponius Mela about the navigability of the Northern Ocean. Going into the Indian Ocean, we have this cartouche with text in it on Martellus's map, which is now legible. And there is no corresponding text on Waldseemüller's map. So the text on Martellus talks about a fish called the narco that makes the fisherman's arm and whole body numb, even through the fishing pole and line. For whatever reason, Waldseemüller did not copy that text. So again, he was making judicious use of his sources. And if we look at the text block in the lower left corners of the two maps, we can see that the text on Waldseemüller's map is much longer, and he's talking about the discovery of the New World, which hadn't happened when Martellus made his map. So the length of the texts are different, the subjects of the texts are different, and yet we see that the entire last phrase is copied from Martellus. So even when he was talking about a different subject, Waldseemüller kept his eye on Martellus's map, kept his eye out for things that he could make use of. So again, it's a very judicious and creative use of his source. So I want to talk about what I found to be one of the most interesting parts of Martellus's map, which is southern Africa, which we see all of Africa here in a multispectral image from Martellus's map. Here are the mountains of the moon, which are the traditional source of the Nile. If we zoom in, we see that the Nile system continues much further south than the mountains of the moon, which is quite surprising. Here it is. We also see many named cities in the southern part of Africa. And this is particularly surprising for two reasons. First, if we look at Ptolemy's knowledge of Africa, we see that the mountains of the moon are essentially the southern limit of his knowledge. He doesn't really depict anything south of the mountains of the moon, certainly no extension of the Nile River system further south, and certainly no named cities. Moreover, when we compare the Yale Martellus map on the left, its depiction of southern Africa with the depiction of southern Africa on another world map by Martellus, the one in his island book, we can see a very striking difference. In the island book on the right, there are a few sort of desultory mountain ranges, but all these place names we see are coastal place names. So basically there's nothing aside from some hypothetical mountains in the southern part of Africa. Whereas on the left in his world map at Yale, there is abundant geographical detail, this huge river system, named mountain ranges, named cities, lakes. So it's clear that Martellus had found an additional source of information about southern Africa. What could that source be? I propose that it was a map called the Egyptus Novello, or New Egypt map, which was created around 1454 and survives in 3 manuscripts of Ptolemy's geography, all of them from the workshop of Pietro del Massaio. The information in this map is thought to have been transmitted to Europe by quote-unquote Ethiopian delegates, and I use quotes because at this time Ethiopia was basically anything south of Egypt. Ethiopian delegates to the Council of Florence in 1441 to 1443. Ethiopian delegates were present and were questioned about the geography of their homeland. And we have some record of that questioning. And essentially, the European members of the Council of Florence said, well, what you say does not agree with Ptolemy, so you must be wrong. But it's easy to imagine someone a bit more open-minded taking the delegates aside and asking for more details. So here is one of those Egyptus Novello maps in a manuscript in the BNF. I'll rotate it to put north at the top. So we have the Mediterranean at the top, the Nile Delta, the Red Sea, and the Southern Ocean. So this map is showing us, although it takes a minute to put it together, almost the whole length of north to south of Africa. And it has many named cities in the south. I show a detail here giving some idea of the number of named cities there. And it has this very elaborate river system going quite far to the south, almost to the Southern Ocean. So in the Egyptus Novello map on the left, we can see that this river system seems to be, well, either coming from or flowing to the east, but then it's cut off. And what's really amazing about the Martellus map is that we have some of the same geography not cut off. The same river system continues further to the east. And so I mentioned that there are 3 surviving manuscript exemplars of the Egyptus Novello map. They are all cut off in the same way. They're all cut off on this meridian. And so what's special about the Martellus map is that it has embedded in it a more complete version of what is an African map of Africa from the 15th century. It's really quite remarkable. So here we have some of the named cities on the Yale Martellus map. And I've selected ones that are in the part of Africa that's also included in the Egyptus Novello map. And so we can see, are they more or less the same cities on the 2 maps? So I'll go through and show that they are. So on the Martellus map here, we have a city called Gama. And on one of the Egyptus Novello maps, it's Gama. It's the same city. Here it's Huogi and Huogi with 2 G's on the Egyptus Novello map. We have Sadaya Magna and Sadaicion, so not exactly the same, but very similar. And we have Damat Arum and Damot Arum in one of the Egyptus Novello maps. So the relationship between this depiction of Southern Africa in the Martellus map is extremely similar to what we have in the Egyptus Novello maps, with the difference that, again, it extends further east. It gives us a more complete version of this 15th century African map of Africa. One more example, Gafut and Gafat. We can confirm that what we're seeing in Southern Africa comes from Ethiopian sources, and we can confirm it in what I find to be an interesting way. If we look at the southeastern tip of Africa on the Martellus map, it has interesting geography. We have a barrier of mountains and a channel of water that cuts north and south. If we compare that with Framauro's world map, which was made in the middle of the 15th century, about 1455, which we were talking about briefly before we got started, the map is actually oriented with south at the top. I've rotated it to put north at the top. If we look at southeastern Africa, here it is. And we have a very surprisingly similar configuration on both maps. There is a channel of water running north and south that basically cuts off the southeastern tip of Africa. And Framauro tells us in the plainest possible terms that his depiction of this part of Africa comes from people from Africa. He says, because to some it will appear as a novelty that I should speak of these southern parts, which were almost unknown to the ancients, I will reply that this entire drawing from Sato southwards I have had from those who were born there. These people are clerics who, with their own hands, drew from me these provinces and cities and rivers and mountains with their names. All these things I have not been able to put in due to order I have not been able to put in due order for lack of space. The important thing here is that he's saying very clearly that his depiction of this part of Africa comes from people from Africa. And that confirms that what we're seeing in Martellus's map is a 15th century map of Africa. So again, what's really important in this part of the map is that what we have in the Martellus map extends the information, the geographical information that we have in the Egyptus Novello map on the left, extends it further to the east. So, and to my knowledge, the Martellus map is absolutely unique in that regard. It is the only record we have of that further, that larger image of Southern Africa, again, according to African sources. One interesting feature in this map is this city, which, as we can see, has crosses above it. And if we zoom in, it says the city of Gatiana, where Prester John lives. So I think it's quite interesting that we have a depiction of the Christian city of Prester John, who was a essentially mythical Eastern monarch who was thought to be Christian, and the Portuguese went searching for him for several decades, wanting to establish an alliance with him. This appears on Martellus's map. This was quite surprising to me, and again, without the multispectral imaging, would be entirely invisible. The Ethiopian delegates to the Council of Florence were asked about Prester John, and they asserted that he was a king in Ethiopia, which is to say in Africa, south of Egypt. So the presence of the city accords with the little that we learned about the Ethiopian vision of Africa from this record of this conversation at the Council of Florence. We also have another city with a cross over it, further to the southeast in Africa, which we see here. It's Delanesso Civitas, the city of Delanesso. I have not been able to figure out what this city, this Christian city, so far to the southeast in Africa is supposed to represent, but it's quite remarkable. One other question that arises, what is this part of Africa, this southeastern tip of Africa? We look at another multispectral image of it. We can see that there is a barrier of mountains, and then the channel of water that I mentioned before. We have three what we can call frontier cities, which are to the west in this peninsula that's cut off from the rest of the continent. We can see that this barrier of mountains continues around the north and eastern parts of this peninsula. And the channel of water continues into this peninsula. And there are frontier cities against the mountain range to the northeast as well. We don't know whether this this mountain range continues all the way around the peninsula, because there's a banner at the bottom of the map that sort of covers up that part of the peninsula. But there is a very large lake in this southern tip, southeastern tip of Africa. And there's actually a label in the lake, and it would be absolutely fascinating to know what this lake is called. And I asked Roger to reprocess this part of the image many times, and this was the best we could get out of it, unfortunately. But we have this lake with this river flowing towards the barrier. And then these, on the other side of the barrier, we have these lakes that seem to be the sources of the huge river system that flows northwards in Africa. So what I'm suggesting is that what we have here is a depiction of the terrestrial paradise. We have this remote corner of southeastern Africa that's separated from the rest of the world by this barrier of mountains and barrier of water. And we have within it the source of the Nile, which is, of course, one of the rivers of paradise. So that seems to be what we have here. And with regard to the location of paradise, of course, it's usually located in the east. And we can see that in a Mappamundi that's joined to a nautical chart. So we have nautical chart on the right, Mappamundi on the left. Here's the Mappamundi. We zoom in. Here we have Europe, Africa, the Indian Ocean, and Asia. And just off the shore from Asia, which is off the eastern shore of Asia, which is to say in the easternmost part of the world, we have this island of the terrestrial paradise, which is surrounded by mountains, which we see here. But paradise is also sometimes located in southern Africa. And we can see that on the world map by Albertine de Virga, which was made in the early 15th century. I wish I had a better image of it to show, but the map's whereabouts its whereabouts have been unknown for several decades. So this is the best image we have. Just to orient ourselves a little bit, here is Europe, Asia, and Africa. And if we zoom in a little bit, here are the outlines of Africa. And in the very southern tip of Africa, we have this large circular element, which is the terrestrial paradise, and we have the rivers flowing north from that point. One other example, here we have the so-called Genoese world map of 1457. Again, just to orient ourselves a little bit, here's Europe, Asia, Africa, and the southeastern tip of Africa. And if we zoom in a bit, the text there says, in this region, some have depicted the terrestrial paradise, but others have said that it is beyond the Indies to the east. But since that is a representation of cosmographers who have given no description of it, therefore an account of it is here omitted. So a clear statement that some have depicted the terrestrial paradise precisely in the southeastern corner of Africa, in this peninsula that juts out into the Indian Ocean. So a few conclusions. One of the gratifying things about this project is that it has turned this map, which was a great unstudyable object, into something that's studyable in all its aspects. The images of mountain ranges, rivers, lakes, cities, the descriptive texts, the place names, all of it is now studyable. Another exciting aspect of this project is being able to finally compare Waldseemüller's world map and Martellus's and see just how close the relationship is between them. And in particular, it gives us a window into how Waldseemüller went about creating his world map of 1507. We don't have his journal or diary or anything of that nature, but by looking at how he made use of one of his most important sources, we get some insight into his methods. We can see that he was very keen on copying descriptive texts from Martellus's map, but he chose other sources for his place names. well, I should say he chose the outlines of Asia and several other things, including the descriptive texts from Martellus's map, but found other sources, more recent sources for other things. So again, it's an insight into how he went about making his map that we can't get from any other source. And of course, the fact that the Martellus map has sort of buried within it this 15th century African map of Africa with an image of paradise at the southeast corner of the continent is, I think it's fair to say, also quite remarkable. Thank you very much.
Well, thank you so much, Chet. Maybe you should can stop your screen share so we can see you.
Sure. Yes. There we go.
So do we have questions? I don't see any hands yet. Yes, William.
Wonderful. Thank you, Chet, so much. Just off the top of my head, any comparison of the location of the paradise to things like the Zambezi River and south there?
Do you mean does the Zambezi River connect with this? I'm not sure.
Okay.
So it's very challenging trying to connect what we see in the Egyptus Novello maps with standard European geography of Africa. So I've written a book about this project, and I did what I could in that book, but it's a challenge.
Yeah. Good. You didn't mention the Tordesillas map, which we have a copy of. Oh, no,
I'm sorry.
The Toscanelli map, not Tordesillas. Toscanelli.
Yes.
Because we don't have any copy of it.
Because we don't have any copy of it. That's precisely why I don't mention it.
Okay,
So.
super.
Niden?
I was interested in the different kinds of ink, and presumably those were different colors of ink. I noticed some of the others, there were blue and red and black, and possibly, I would guess gold probably wouldn't decay like that, but the other colors, do we know what those inks were?
We don't. And this was a surprise when we started processing the images, when Roger, I should say, started processing the images, this fact that the inks were different and that they responded in this different way. So when we started the project, we had no idea that that would be the case. And had we known that to start with, we would have tried to bring some XRF equipment or some way to study them. So to do that now would mean a new project, and yeah, some money and negotiating access again and making the case. So it might be better to wait a little while for that one.
So if you had known what the inks were, you might have chosen different frequencies to expose them to?
Well, it wouldn't, the frequencies of light wouldn't, that's a very good question. The frequencies of light would not have, choosing different frequencies wouldn't help with that. It would have been a different technology that would be helpful.
Charlie, you have a question?
Sure. First, thank you for that wonderful presentation. And I have a question about multispectral photography. Was it developed for historical manuscripts the way you're using it, or did you all borrow it from another technological space?
We borrowed it from another space. So it has been used for satellite imagery, for sort of teasing data out of satellite imagery. And it was only in, I think it's the 90s that really the technology was applied to manuscripts. And the early versions of multispectral imaging systems were not good in the sense that so white light has all the different frequencies, and the method they used was to shine a white light, a bright white light at the object, and then put a filter in front of the camera so they would just have the one frequency. But they were bathing the object in all this energy so that the temperature of the object would increase, which no curator wants to have anything to do with. So then it was really when they started to use LED lights that can shine just the desired frequency and use much less energy that the technology really became, much safer to use and much more acceptable to use. Thank you very much for hosting. It's been a pleasure to see you all again. And it's frankly wonderful that the Sarum seminar continues to go strong.
And it's great to see how you've continued to go strong.
Yeah, you bet.
Is anything bringing you back out to the Ramsey collection anytime soon, Chet?
I hope so. I always love to be there. So I think I'll be there in June, actually. I won't be speaking at a conference, but I'll be attending. So
Come to our potluck.
Yeah.
okay, very good. If I can, I will.
Yeah, terrific. Try coming. Yep.
Yeah, our
Okay.
potluck is in early June, and announcements will be going around about it as we get closer to the date.
Okay. Please copy me.
I will.
Good.
Okay.
It'd be good to see you again.
It would. Thank you very much.